in 5, 4, 3, 2, 1, 0. Yeah. Good time. Over the top. There's your event, and there's your parachute. Very good.
All right. That's better than the last one. I was close.
We may get our rocket!
This is a custom rocket concept by Scarlett, inspired by the toxic waste hard candy. The primary design element here is going to be these 50-gallon drum-shaped fins. And as we watch the fin can come together in just a second, we're going to look at what's required to make these custom fins and ensure that they fly safe. This is the final drawing that you import into OpenRocket. Notice that the root edge has to be on the bottom, and you need your fin to be black and the background to be white for best results. To make this, we went into Inkscape. We took sort of 3 ellipses that looked like a nice forced perspective on the lids, and then just added that over a simple rectangle. We then unioned all 4 of those shapes, and then did a difference to clip the root edge straight. That will give us the shape for the simulation, but we need to add the fin tabs so that we can laser cut these pieces. To do that, we took a rectangle the size difference of the outer diameter of the motor mount tube and the outer diameter of the body tube. And we then made another rectangle the depth of the notches that we put in the centering rings. For the centering ring, we're going to reuse a parametric model we've used on a few rockets. This is in a program called OpenSCAD. It's really kind of convenient for this. What we're going to do here is just we're going to programmatically say, take a centering ring the size of the inner diameter of the body tube. Then what we're going to do is we're going to spin it around just in proportion to how many fins that we want. Then we're going to center where we're going to do the notch so that we don't have to worry about the arc, so that that longest dimension of that cut is going to be right in the center of the arc. And then what we're going to do is we're going to go from the middle, we're going to take off of the radius the length of the tab. Then we'll just loop over that, cutting those notches out for the number of fins. And then we'll come in at the end, and we'll drill a hole through the middle for the motor mount. You don't have to change that file at all. This is what makes the parametric modeling pretty easy. So what we do have is we go over here. There's a few parameters in here that we didn't need for that other file that we use in other projects. But all we need to do is update these. We get the calibers out. We do our measurements, and we're pretty good to go. We do leave these a little bit large and sand them in, so we don't see a lot of complicating factors here that you wouldn't want for real manufacturing, like the curve of the laser and such. We then export that to a scale vector graphics format and send it to the laser cutter. And with those cut out and assembled, it's of course time for some fillets of glue. Got to make sure these stay on nice and secure. As we finish that up, the next step is going to be to cut the slots. This is a pretty thick wall tube, so it takes a little bit of trying here. We do want to make sure that we actually do multiple cuts and not just a single. Off camera, I had lined this up with the fin can and marked those on the tube, and then used a piece of angle iron to draw the lines out. Now we're going to drill and mount the shock cord. I decided to drill through a fin just to make sure that it had real strong attachment there. Then we're going to take a piece of Kevlar cord that's just barely smaller than the holes we drilled, making that process a little tedious there, but we'll feed that through. And then we'll just feed it back through the figure 8 knot that we tied on the top to give us a nice figure 8 follow through, and give ourselves a little stopper knot at the end. Once we get in that, the Kevlar cord is a little slippery. It does like to come untied, so we'll put just a little dab of glue, mostly on that stopper knot, just to try and keep everything in place. With that, we'll pass the shock cord through. We'll line everything up, and then we'll put glue in for the top centering ring. Once we start to push it in, we'll pause halfway through to put some glue in on the bottom centering ring that'll hopefully flow down once we put this vertical there. And then we'll let that set. We do see a little bit of glue coming out the bottom, so that at least makes us confident that we have some connections and a decent amount of glue. We'll flip it over, and then we'll put fillets on the underside. Careful on the center tube, because we do still want to put a retainer in, so we don't want too tall of a fillet. We're not planning on doing anything too crazy, so we're not going to worry with internal fillets along the fin edge and the body tube, but we will put a few passes of fillets on the outside of the body tube. Then we'll come back here, and as you'll see, we'll just CA glue that motor retainer in place and give a nice little bead along the bottom, just to make sure. We'll then come back in and we'll put the 1010 rail button right at the bottom centering ring there. And then where we can reach it in the tube, we'll put one up here in the front. Those are always a little bit tedious to align, but putting them high up does at least make it a little easier. So with that in, now we'll measure out at least a body tube length to tie a knot for the parachute. I normally use a butterfly knot there to tie the nose cone on. I think I gave up and just used a bowl in there. Any of those should really work. We follow up with little dabs of glue on the nose cone just to make sure. So we'll add that parachute, then we'll come back and add this chute protector. It's really convenient, especially something this size, to not have to just go through wadding and things. And that together with this larger diameter rocket will make it pretty easy to pack and lots of fun for the kids at the range. I'm always paranoid about having too sharp shock force on things like the 3D printed nose cone and things like that. So I will add an elastic element here, and that'll finish up the build portion, and we'll switch over to the sim. One thing that we won't show here is we do this iteratively, right? We start out with the sim before we cut anything to try and size the overall fins appropriately, make sure that we're heading in a safe direction before we start to manufacture any of the parts and get ourselves painted into a corner. So we'll do that to start with, and then what we'll do is we'll come back and we'll do our as-built adjustments. One of the benefits with the 3D printed nose cones is you can adjust the infill to get the weight that you need. We'll show that another rocket on this series. But we can see that we have a pretty heavy nose cone there. We do have to come back. Once we remove all the motors, we find the center of gravity, we find the difference in the weight. We'll add this mass component and shift it along the axis of the rocket until the overall weight and the center of gravity match the build. So now we'll go back and we'll turn the motor mount back on. You can see we've tried a few different motors here. Not all of them are going to really sim that great, but we start with a wide net just to see what's possible. So now on the simulation tab, you can see that some of these have pretty high deployment velocity. Probably wouldn't really want to fly that even with that load limiter with the elastic in line. We see we did have to go to a larger parachute from the original just because we ended up being a little heavier. So we don't want that ground impact speed being unsafe either. So with the larger parachute and these simulations up to date, a few of these motors look pretty interesting. And then with that done, I'll show you real quick where you go to import the custom fin designs. So we go to freeform fin here, and down on the bottom, you can see where to import, and you can see that we've already done that import here. One important thing to note is we do have a warning here. Make sure to follow all the safety protocols and convince yourself that your rocket is stable before flight. A short video like this can't cover all those safety considerations, and it's always the responsibility of the flyer. Thanks for watching.